All right, continuing the last video, it's kind of hard to go between StatCrunch and my stat lab and my document camera. So here we are. All right, so in a previous video, I showed you that we can find the margin of error for when calculating a confidence interval for a population mean by taking plus or minus z critical. Well, I should say the margin of error is equal to the z critical value, and the plus or minus doesn't really matter in this case. That's a given. So we have the z critical times the population standard deviation divided by the square root of n. With a little bit of algebra, we can solve for n, and again, that was done demonstrated for you in a previous video. And we find that n can be calculated, or at least approximated, by taking the product of the population standard deviation times z critical divided by the margin of error, all squared. All right, so we have to fill in the parts. So we are being asked to calculate a 95% confidence interval. So for reasons I've discussed in previous videos, that will be 1.96. So I've got these reversed. This is the z critical. So multiplied times the population standard deviation, which is 48. It's given in the problem. And we have a desired margin of error to be within plus or minus 5 minutes. Again, that goes back to the plus or minus z up there, but we just only need to use the 5 there. So put that in your calculator, you get 354.04, round up as always, so we get 355. If we needed a 99% confidence interval, the only thing we would change would be the z critical, which is 2.576. Same population standard deviation, same desired margin of error. We get 613 point stuff, always round up to get 614. So I don't know if we're going to need that anymore or not. I forget what else we have. So let's go on to the next question. So this question, let me minimize this. This question will actually use StatCrunch. No, we won't use StatCrunch, actually. So let me bring this back up. What we have here is we have that the confidence interval, it's really just being able to understand that confidence intervals come in different shapes, forms, and fashions. So I could write this as, let me get another sheet of paper so I can demonstrate this instead of speak it through. So what they have given is they have given that 0.33 less than p less than 0.555. This is equivalent to writing it in the standard confidence interval form. We can also write this, as I explained in earlier in this video, actually, too, that we can write this as our estimate from our sample plus or minus our margin of error. So how can I find p hat? Well, p hat has to be the value smack dab in the center of that confidence interval. Well, the easiest way to find the center of a confidence interval is just to take the numbers and add them together and divide by 2 to get the average. So in this case, the center of the interval has to be 0.444. And then plus or minus what? Well, all I need to do is take this number or this number and see the distance from the center to it. Well, if the center is 0.444, the distance up to 0.555 is just 0.111. At the same time, if I have the middle at 0.444, I can subtract 0.111 to get the lower bound of 0.333. So that's really all that's going on there. It's a very simple question, but it just emphasizes, I guess, that confidence intervals can be expressed in different ways. At least that was the motivation for me putting this problem on your on this demo and on your assignment. At least I'm sticking with it. All right. Similar problem, right? So it looks like, in fact, it's exactly the same thing. I'm not really sure why I included it, but let's work it out. So the standard deviation for the population looks like it is 19. It's given in the problem. We're working on a 95% confidence interval, so the Z critical when the population standard deviation is given is 1.96. And the desired, let's see, so we want the sample mean to be within 6 IQ points of the true mean, so we need the margin of error to be 6. So we can put that in our calculators. So I'm just going to take 19 times 1.96 divided by 6 and square all of that. I get 38.522. Again, always round up. So the answer would be 39, as I put there. Now, this is a relatively small number, and this answer comes to the point that, you know, sometimes we have to make estimates based on small numbers. You know, IQ tests, my wife is a school psychologist, and she gives IQ tests, and they're very time consuming and they're very expensive to give. So if she's going to give an IQ test to a group of students and try to generalize from it, she would want to select a small group. And it kind of comes to the point, if you're working for BMW and you want to do some crash analysis and you want to you know, determine the average cost of a car repair of like one of the fancy BMWs going at 35 miles an hour into a brick wall, well, you can't go to the CEO and say, well, I'd like to have a, you know, 150 BMW sedan so I can go here and crash them. You probably have to make your determination on maybe 2 or 3. So anyway, that's the point here. Sometimes we get in situations where we have to make estimates on small samples. Wow, okay, that's it. I thought there was another question. All right, take care.